Hey everybody! Today we're talking about multiplying fractions with whole numbers. Let's take a trip back in time. Do you remember when we'd have three equal groups of objects and you'd be asked to find the total number of objects? For instance here, I have 3 plates with 5 donuts. If I wanted to find the total, I could add 5 3 times. That's repeated addition. But we also learned that we can use multiplication instead of repeated addition. Since I have 3 groups of 5, I can add 5 3 times, or I can multiply 3 by 5. In either case, I'll get 15. So today, this will be similar, except we're going to work with fractions. Here I have 3 plates, and each plate has 1/2 of a donut. If I wanted to know the total number of donuts, I could add 1/2 3 times, still using our friend repeated addition. And I know that that is, anyone? 3/2, correct. Now, what you're all wondering is, can I still use multiplication? Yes, you can. Here I have 3 groups of 1/2, so I can say this is 3 times 1/2, and I still get the same answer. But you're wondering, how? Well, we'll get to that. Let's try one more example. Here, each of my plates has 3/2 donuts. So, if we wanted to know the total number of donuts, we could still add 3/2 3 times. And we know that that comes out to, anyone? 9/2. Yes, because we add the numerators and leave the denominators. So, can we use multiplication? Yes, we can. We have 3 3/2, so we can say 3 times 3/2. And we'll still get 9/2. Now, back to the question. How does this multiplying work? Well, let's look at our 2 examples next to each other. In the top one, my 3 1/2 came out to 3/2. In the bottom one, my 3 3/2 came out to 9/2. Do you see any kind of pattern here? Well, it has to do with the numerators. You'll see that our denominators stayed the same, but in our answer, the numerator is the product of our whole number and the numerator of our fraction. And some of you are wondering if these improper fractions, 3/2 and 9/2, can be written as mixed numbers. And they can. In our first example, our 3 1/2, if we try and put those donuts back together, you'll see we do end up with 1 1/2 donuts. In our second example, if I try and put all my halves back together again, you'll see that we end up with 4 1/2 donuts. So now that we understand multiplying our whole number by a fraction, some of you might be wondering, is that the same thing as if I multiply the fraction by the whole number? Well, as you may have learned, if our only operation is multiplication, we can multiply in any order and we will get the same answer. But does it represent the same donut situation? Well, in the first one, I read that as 3 groups of 1/2. So in the second one, do I read that as 1/2 groups of 3? Well, you can, but it makes more sense to me to just think of this as 1/2 of 3, kind of thinking of our multiplication sign as the word of. So is this the same donut situation? Well, 1/2 of 3 is a little different. That means I started out with 3, but I take 1/2 of the 3. How do I take 1/2 of 3? Well, if I break all my donuts into halves, then it'd be a little easier just to take 1/2 of them. I'll eat the other half later. And you see that 1/2 of 3 is 3/2. So I think you've pretty much got the hang of it, but before I let you go, I want to look at it just one more way. And to do that, we're going to take a little trip back in time. You remember long ago you'd be given a nice pretty rectangle cut into nice pretty squares, and you'd find the area by just counting the number of squares. Then you learn the reason you could count up those squares and count those as the area is because each of these squares was 1 unit by 1 unit, which we know is 1 square unit. Then you learned that you could find the area of rectangles by multiplying their side lengths. So here we would just have 2 units by 4 units, which would be 8 square units. But what if we aren't given perfect unit squares? What if instead our squares look more like rectangles, where one little rectangle is maybe 1 unit on one side, but maybe a half unit on the other side? Well, this isn't really any different. This is just 1/2 unit by 1 unit, which is 1/2 square unit. Now, what if I wanted the area all the way across that row? So 4 of those 1/2 square units. How could we find that area? Well, here I'm just looking at a rectangle, part of my bigger rectangle, and its dimensions are 1/2 unit by 4 units. And as we learned, we can multiply that fraction by the whole number by just multiplying the numerator and leaving the denominator, so we have 4/2 square units. Now, if you're wondering if that's the same as 2 square units, well, wonder no more. You are correct.